So this is the last lecture lab period. Next week is time either for working on your project or catching up on labs. So it'll just be all you asking me questions. Okay. So I have some new things to show you, just little things. We have the final is, I think, Monday, is that right? So next week is, yeah, so we meet Monday, Wednesday, 12:30. So that is Monday, December 13th at 12. And probably what I'll do again, the last time in the spring for this course, the third test had sort of two parts. And one was sort of making a database. So I will describe some entities and some relationships, and you will write the code that defines the database, insert a couple of records, not have a user do it, but you do it in code, and then maybe some basic query. So you will be defining, so there'll be a part where you're defining the entities and the relationship and so on. And then there'll be another part where I'm going to hand you a database with definitions and some basic routes. So there'll already be some Flask with routes and a form. And then I'll ask you to add to it. So maybe I will have an insert of one kind, and I'll ask you to do an insert of a different kind, or maybe I'll ask you to add a delete route or something like that. So, or make a data table. So there'll be one where it'll be more from scratch, and another one you'll be able to copy things from other projects, but I won't hand you files for one of them. And for the other one, I'll hand you a lot of files, and I'll hand them to you as I've been normally handing you things with the folder structure. And so if you put it in your virtual environment, it should be something that works. And then you will add to the thing that works. Okay. So that's what we're expecting for that third test on Monday of finals week. And next week is no lecture, no lab, just time for catching up and working on your project. Okay. So any questions before I present the new stuff for today? It's just a bunch of little things. And okay, so in SQLAlchemy, they have this programming concept of the relationship. So you can say, what did we have? We had a relationship between like a song and the album it was on, or we had a relationship between the song and the person who wrote it. And we could use those relationships to get the information out of our database without explicitly writing a SQL join. Occasionally, and those are what in SQL language you would refer to, if it were a database course, you would refer to as a natural join. When you join one table to another on a foreign key, then that type of join, that type of connecting two tables is known as a natural join. And we want to do a more explicit join where we are controlling it ourselves. So sometimes you're doing a join that's of a different variety. or sometimes we might want to mimic more what would come out of a SQL join. Maybe we want the data in that kind of a format. So that's what this first thing does, is sort of, instead of using the relationship, it will sort of build the sort of join into the query. And so I'm just returning to some old databases and adding this new type of join. So this one is going back to the Beatles. So I'm copying this and putting it into the SQLAlchemy here. And that part alone gave some people on the second test, on the Flask test, some issues. You have to be ready to put the files, have a working system and put your files into the right place. That should take 2 minutes, not 15 or 20. Okay. And close a million things. Make sure I'm in the right folder, open folder. I'm in the SQL V&V, that's where I want to be. And this was the Beatles 2. And we've seen a lot of this stuff before. There was a table, there's a many-to-many relationship between the artist and the song. Most of the Beatles songs are thought to be written by the combination of McCartney and Lennon. And so most of the songs were written by many, meaning more than one artist, and the artist wrote more than one song, so it's a many-to-many relationship. And one way to do that is to have this association table. And so this is the table that establishes the many-to-many relationship. So there's an artist ID and a song ID, they're both foreign keys. There's an album, which has an ID, a title, and an image, and there's a relationship to song. Then there's a song, which has an ID, a title. The song is on one album. The album may have many songs, but the song is on one album. We're not doing the greatest hits albums here. And so that was a one-to-many relationship, and here's the making of that relationship. And then the song was written by an artist. That's a many-to-many relationship. And then here's the artist, an ID, a first name, a last name, and then the artist has a relationship to song, which was a many-to-many, and so it was put through this write table. We set up the database. We read a file of Beatles albums. We read a file of Beatles songs to populate 2 of the tables. I populated the artists just by hand because there were just 4 of them. And here is me entering data into the write table. So the first song was written by McCartney and Lennon. So this is so I'm making that relationship between the songs, and then so this was one. So this was Lennon and McCartney writing the first song. This is Lennon and McCartney writing the second song. Lennon and McCartney writing the 6th song, and this is George Harrison writing the 18th song. Here was some just query, and we're using the relationship. So in this first query here, we're using the relationship. So I got the first song, and then that had a relationship to artists, and I'm looping through the artists that wrote that song. That was previously there. And here I'm looking at the artist, getting the first artist and looping through the songs. So there I'm working with the relationship. So that's the old stuff. Now I want to show you more explicitly the join. That's not what this was. This was another this is me explicitly, instead of doing a sort of a select all, this is me sort of explicitly saying what files I want. So I said I wanted the artist, and I'm going to get the ID, and I'm going to label it as ID. And then I'm getting the artist's first name, and I'm labeling it as first. So this is me specifying what I want and renaming the files. And we saw that on Monday, I believe, the more difficult, sort of more complicated queries. And now here's the new thing, a join. Okay. So before we used the relationship, the SQLAlchemy relationship, to relate the album to the songs. But here I'm doing it more specifically in the query itself. So I'm querying album and song with a filter that the album ID is equal to the song album ID. So that is a join. And so we got that effect through the relationship, but we can also get that relationship through the query. So now we have sort of two ways of doing it. And I won't force, I will say, like on test 3, give me these results, but I won't say you must use a join or you must use a relationship. I would just let you just handle it one way or the other. And so this was the relationship between the album and the song, which was a one-to-many. And so that was a simpler relationship. And now here is the relationship between the song and the artist, which goes through, because it's a many-to-many relationship, goes through that table. And so here I'm querying the song and the right table and the artist. And I'm filtering on the song ID equaling the song ID in the right table. And with the right table, you need this extra little C in there. I don't know why you just do. And then here's the other side relating the artist ID to the right table with a little C ID. So let's just, there's no Flask here. This is just running it. And in my Flask, I have to start my VNV, but I did not here in my SQL. So, but here's the first, this first join was the name of the album and then the song. And so the name of the album was coming from the album table, the name of the song from the song table, and there was a relationship. And instead of working with the relationship in code, I was doing more the sort of making it happen in SQL. So I sort of, again, sort of an explicit join in the database query. And then here is the relationship between the song and the artist in the second query. And that was joining 3 tables because it was a many-to-many relationship. So there was this bridge table is what I'll normally call it, but I think SQLAlchemy likes to call it an association table, and or sometimes a connection table. And so there were two filters there to get the relationship on sort of both sides. But that's an explicit join where you, instead of relying on the relationship, you rely explicitly on you working with the filter, which is the IDs. So we can explicitly work between multiple tables, or we can work with sort of one table and its relationship to other tables. So we've got two ways of doing these things. I didn't want to shortchange you and show you only one way. So that was the explicit join. Now I'm going to go back to Planet. I want to show you, we've been doing the other thing. We have been, you know how I love JSON. We've been using APIs. We've been like my famous Nobel Prize or Chuck, the Chuck jokes, or the Nobel Prize, or the XKCD site. These are all APIs where they connect to, you go to somebody's website and you get the JSON information, and then from there you can work with the JSON and do what you want with it. And now that we have a database, I want us to make an API. So I want us to make a route, which is a website that will put out JSON. So for us to make an API. And I just keep adding to Planet, but I'll do it sort of one by one. Well, I already have a bunch of Planet stuff, but the new thing in this one right here is the API. Copy that. This VENV, the SQLAlchemy. And I'm going to look at the. Shut up. Okay. So where's my routes? Here are my routes. Okay. So I did the delete previously. Now here is the API route. So we're going to output some JSON. So we need the JSON module. So we'll bring in the JSON module. And then I'm going to make a route called Planet API and have this function that matches that Planet _ API. I already have a query where where did I do the querying? Up here, I did the querying and made a list of dictionaries. So I have a list of dictionaries. And you remember this weird database specific field that we didn't like, it was more behind the scenes and not real information of our it's not sort of real information in our database. It's more some behind the scenes working thing. And so I am looping through I have this results _ dictionary is me putting the results of a query into a list of dictionary forms. And I'm looping through that list of dictionaries, and I am getting rid of this property. And it's not only that I didn't want it, it's that it didn't work with it. So it's not just me sort of being finicky and saying I don't want to show them this. It wasn't working if I had this property. So this is me getting rid of that property. that weird property. We didn't want to show them anyway, and we need to get rid of it. And then here is us using the JSON library to take this and make a dictionary out of it. So here I am, app planet routes and Flask run. And it's not working. Maybe I do need to, for Flask. Okay, I didn't need it for SQLAlchemy, but I do need it for Flask. Let's try it again. Okay, so here is my default route is the table. I also had a data table. And now I've had a delete. So this is reminding me what we had already. I had a delete. So I can delete any of my planets. Looks like Pluto's already gone. And I have now an API. I have an API route. And it produces some JSON. That's what we mean by an API, is a website that spits out some data in some kind of JSON form. So we have a list, so it starts with a square bracket, so that's a list. And then we have a list of dictionaries, and then here are the dictionaries with the information of each of the planets. So that is, so that's an API. We could massage the information into another form of JSON if we wanted, but basically I just wanted to show you something that is us making an API. Since we've been using them all through the semester, I wanted you to know how to make one. Okay. And we've done this before, this JSON dumps. And instead of making a page with HTML, I don't want HTML, I just want JSON. So this is way back to like the first thing in Flask, where you just return some information and slap it on the page. We're not putting it into HTML and then using any kind of Jinja. It's just right onto the route. Write something, return something to the route. And in this case, it's JSON. Okay. So that was an API, and that's what the lab will be, to take one of your previous things and make a Flask route that is an API. In this next one, I'm going to have a slightly more controlled data table. So again, it's the same stuff. I'm going to have a data table and a data table 2 route now, with just a slightly improved. So what we get, the new routes. So in this, one of the last times we repeated the one of the last times I showed a query where we're explicitly naming the fields we want. So that's part of this new data table, is rather than to do effectively a select star and just grab everything, and then I have to worry about things I don't want, I explicitly grab what I want. So I said, grab me the ID and the name and the distance and the period. and query that, and then turn it into a bunch of dictionaries, and then send that information results underscore dict2. That's getting sent over to this data table, and I have a new data table 2 HTML. And I'm looping over. I don't have to get rid of I don't have to get rid of the weird underscore SA instance thing, because that wasn't in my query. Now, instead of doing select star, I'm saying what I want, and I didn't ask for that thing, so I'm not getting it, so I don't have to worry about getting rid of it. So that's one thing. And I'm putting IDs in this table, so we should look behind the scenes and we'll see these IDs. And what else do I want to show you? This thing has its slightly different layout. It's a data table layout 2. Data table layout 2. Instead of just saying that the table gets the data table functionality, I put in some jQuery code here that says, take the first column, which is for the ID, and it's not visible or searchable. So we're not going to be able to, we won't see the IDs. The information is sort of there, but, and I put it into something behind the scenes, but it's not something that the person will see. Okay, so let's run this. Okay, so here's the table. Here's the data table. That's the first version of the data table. And we see here it has the IDs, it has the name, it has the period, it has the distance. It controlled the order of these things. I didn't have, I sort of lost control over that. And now I'm going to go to data table 2. And I'm not showing the IDs. So this is my data table 2. I'm not showing, I'm hiding the IDs. And also, let's look behind the scenes. And I've given each cell an ID. So here's the 1 for Mercury. So it's there in the table, but we're not seeing it. We're not seeing the 1 because we said it was invisible, but it's there. And here are these cells. It's TD to say that it's a table data item. It's in the database. This was name, and this was the name of the planet with an ID of 1. So this is setting me up. I'm not doing any additional JavaScript or anything here, but I have access to this information of what's the field and what's the ID if I did. So this could be exploited further for me to get, if I highlight some cell, if I gave some interactivity and I highlighted a cell, I could know what record it was because I know the ID, and what field it was because I'm giving the name of the field. So I'm not doing anything more with that, but I'm setting myself up so that I could do other things if I wanted to add some JavaScript here to sort of let the user sort of interact with this data. Okay. So in a data table, you can do a little bit more in the data table in that you can hide things or deal individually with different columns. So what I'm doing here is hiding the first column with IDs. And also in the way I wrote the code, it produced not in data table layout, but in data table 2 not there, but there. I made it create this. I made it create an ID, and then I used the ID, and that gave me those, so that each cell is identifiable. I'm not doing anything with that, but in principle, I can because everything's identified. So that's my improved data table. I named what I wanted in the query, so I didn't have things I didn't want. That also gave me more control over the order of things. I could hide certain columns, and I could give a name, give an ID to each individual cell, so I could know what record it was by its ID and what field it was by the field name. So a little bit better than what we had before. That was improved data table. The last thing, this thing is not improved. This thing's sort of crappy. But there are 4 main interactions with the database. Select, which is when you're getting data out of the database to query it. And so we've done selects. And then there's insert for you to get data into the database. And we've inserted data in code, and we've also inserted data via form. So a user can insert data. And we did a decent job there. We had a sort of a parent table and we had a child table, and we sort of inserted in both. And we had a delete table so we can get rid of information in the database, and that was fairly easy. The hardest one to interact with in terms of forms is the update. So this is a pretty crappy update, but I wanted to show you all 4 of the main database interactions. So again, the main database interactions are select, insert, delete, and update. And so I wanted to show you at least the principle in update, but it's a pretty crappy one, as we'll see. Because it's the one that has the most involved interaction. Where do I want to put that? That's the right one. That is the right one. Paste. And so I just added another route for updating. Oh, I killed the whole thing. All right. So let me close that. The route is now has an update route. I'm going to forms. So there's now in forms, there's an update form. So I had a delete form. Here's my delete form. Now I'm adding an update form. And I'm just going to have all the information and a submit button. The IDs are going to be a select. I'm not going to allow them to change the ID. That would be, the ID is a primary key. I should not allow them to change a primary key, but I'm allowing them to select a primary key. And then they're going to be able to change the name of the planet, the decimal field, the distance, and the period. And then when I run it, you will see why I think it's crappy, but at least in principle, we have an update. So we can say we've seen everything we're supposed to see. Okay. So there it is in the forms. There was under routes, there was a route for it. So here I am importing from forms_planet, the update planet form. Here's the route. Here's the function corresponding to the route. I'm bringing in the form that I imported. And here I'm picking out the planet I want. So that is based on the ID. So the select gave me the ID. So I'm grabbing the planet I want. And then I am changing, here I am changing the properties of that planet. So that'll give me a name, a new name, or new distance, or new period. And then I will change them all and commit it. So that is the, and then I'm requerying the database and sending them back to the data table. And again, that makes sense when you have such a small set of data like the planets. Okay. So we go first to table. The new route is update. Here's the update. I decide to choose one of the pattern planets. I'll do Mars, and I'll call it, I don't know, the red planet. And I don't know, I don't remember these. I'll just, and this is the issue with this, is that's probably too big. The issue with this guy is it should display the old information and allow you to pick just the new things and update some things and not update everything. So that's why I call it a crappy update, but it will update. So I changed this, I changed Mars to 2.36 and 2.7, and I renamed it the red planet, and then the update. And so now, here it is, the red planet, 2.7 and 2.36. So I have updated my database. If I came over here and said Control-Shift-P, that's not what I want. I want to be here, Control-Shift-P, and open my database, open my planet database, show the table. It's in the database changed. So I've updated. So the interaction, the form interaction is needs some work, but in terms of getting updated information into the database, we have that. So it's sort of, I don't know, half right. Okay, and then in closing, I overclosed or closed too many things. The lab is just for you to pick an old database. The very first database we made with just new wave songs, and you make it an API. So add Flask to it and make an API out of it. And that will be the very last lab. Yay. So you made this new wave table with only one, you made this database for new wave songs with only so you already made this thing. It had the title of the song and the artist of the song and the length of the song. You're going to add some Flask. Before it was just SQLAlchemy, you're going to add some Flask. You're going to query this database. You're going to put that query into the JSON format. Make sure you don't have any of that crappy underscore SA stuff. There are two ways to do that. You can either get it and then pop it out, or you can query the database explicitly with the things you want, the title of the song and the artist and the length of the song, and then it won't have those properties in the beginning. but then put that into a JSON format and just do a simple return, and you have an API. So that's the last lab 23. All right. Any questions? Let's stop recording.